Hey, it's Mr. Lum again, and we're going to be continuing some of our Chemistry 11 lessons and talking about mole conversions and yeah. So anyways, on this lesson we're going to be talking about calculating the amounts of atoms within a molecule. And I have a question right here, and it seems pretty straightforward, but it says, how many hydrogen atoms are in 5 water molecules? Now, we should know that water is H2O, okay? And so that means there's 2 hydrogens and 1 oxygen in every single uh, molecule or particle of water. So here I have a picture of 5 water molecules. And so if we want to know how many hydrogens there are, we can just simply count how many there are. So you can clearly see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens in 5 water molecules. Now, mathematically, we can also calculate this by kind of saying there's 5 water. If 5 water, there's 2 hydrogens in every water molecule. And so what we can kind of come up with is that there's 2 hydrogens in every 1 H2O molecule. And if I want H2O to cancel out, H2O cancels out right here, as you can see. And so we just go 5 times 2 divided by 1, and that equals 10 hydrogens. Okay, now we didn't really need to do it mathematically when we're just given such a small number right here. But what happens if we're given like larger numbers? And so we're going to have to start doing it mathematically. So now we have a question right here. It says you have 8 grams of water. How many hydrogen molecules, or how many atoms of hydrogen are there in total? So again, we know that for hydrogen, or so for water, there's 2 hydrogens in every 1 water molecule. So first off, we're going to change grams of water to moles of water. Often, I said this before, but often one of our first steps is always to change it into moles. So I'm going to be taking 8 grams of water, and I'm going to just go 8 grams of water like this. And I'm going to change it to moles. So I want moles to be there, and I want grams to cancel out, so I'm going to put grams on the bottom. Now, H2O, the molar mass of hydrogen is 1, so there's 2 of them right there, so it's going to be 2.0 plus, and the molar mass of oxygen is 16, making the total 18. Okay, so I'm going to put 18 down right there. So if I just did this calculation, I would have moles of water. But what I don't want moles of water. I want to get into particles or eventually atoms. So what I'm going to do is I'm going to go, I want moles to cancel out, so I'm going to put moles on the bottom. And I know that in 1 mole, there are 6.02 times 10 to the 23 particles. Or in other words, molecules. So if I just did this calculation right here, I would have how many molecules of water there are in 8 grams. Okay? Now I don't quite want to know how many molecules of water there are. What I want to know is I want to know how many atoms of hydrogen there are. And so what I know is that there are 2 hydrogens for every 1 water. So just to make sure I'm doing everything right, grams cancels with grams, moles cancels with moles, okay? And water cancels with this water. And so the only thing that is left here is particles of hydrogen. And that's what I want to know. I want to know particles of hydrogen or atoms of hydrogen. So I'm going to type this into my calculator. 8 divided by 18 times 6.02 times 10 to the 23, and then times by 2. I get 5.35 times 10 to the 23. Okay, so this is how many particles. Particles can mean atoms or molecules. Particles of hydrogen. Okay, so now we have another question here. It says you have 3 grams of ammonium sulfate. How many atoms of hydrogen are in this sample? Okay, so first off, we're going to have to calculate the molar mass of ammonium sulfate right here. So nitrogen, there are 2 nitrogens. So 1 nitrogen is 14, so 2 of them is going to be 28. Now there's 4 hydrogens here. 4 times 2 is 8. Hydrogen has a molar mass of 1. So since there's 8 hydrogens, it's going to be plus 8. Sulfur has a molar mass of 32.1. So it's going to be plus 32.1 for sulfur. And oxygen is 16. So 16 times 4 is 64. So the molar mass of ammonium sulfate is 28 plus 8 plus 32.1 plus 64. And that equals 132.1. So the molar mass is 132.1 grams per mole. Okay, so I have the molar mass. I now have the mass of the sample, and I want to find out how many hydrogens there are. So I'm going to go 3.0 grams of ammonium sulfate. Again, I want grams to cancel out, so I'm going to put grams on the bottom, and I calculate the molar mass. And so now I have moles of ammonium sulfate. Okay. I want to get into particles of this stuff. So I want moles to cancel out. And that's going to be equal to 6.02 times 10 to the 23 particles. Now, if I stop right here, I would have the amount of molecules of ammonium sulfate. But I actually want to find out the amount of hydrogen that are present. Now, I'm going to do another little conversion thing, and I'm going to say that, so in 1 molecule of ammonium sulfate, I have 8 hydrogens. Okay, so in other words, I have 8 hydrogens for every 1 ammonium sulfate, NH4, 2, SO4. Okay, so just to make sure I did everything right, my grams is going to be canceling with grams. My ammonium sulfate cancels with my ammonium sulfate. Moles cancels with moles. And so the only unit that I actually have left are particles of hydrogen. And so I can put that in and push equals. So I have 3 divided by 132.1 equals times 6.02 times 10 to the 23. and times 8 equals, and I get 1.09 times 10 to the 23. And that's particles of hydrogen. Now, 2 sig figs, 4 sig figs, 3 sig figs. This is a ratio. It has no significance. It's exactly, those are exact numbers. So since our limiting one is 2 sig figs, it's actually going to be, our final answer is going to be 1.1 times 10 to the 23 particles or atoms of hydrogen.